I'm Paul Jasa, Extension Engineer at the University of Nebraska. I'm going to talk about the soil erosion process and some soil properties when we start looking at some aggregate stability and erodibility of the soil. What I have here is a rainfall simulator to demonstrate the water erosion process. Now what I've got is a series of 5 different greenhouse flats here just to do a little demonstration of the erosion process itself. And what I have here then for demonstration is crop residue management. These are the same soils here. This is strictly a tilled soil, had nothing growing on it this year, so it's almost a dead soil this year. This is the same soil here, and all I did was add about 30% residue cover on top of it. A 30% residue cover, while from that angle it might look like a lot of cover, straight down like a raindrop sees, there's about 2/3 of the soil surface is bare. And so we can detach some soil particles. But research has shown that even a 30% residue cover like this can cut erosion by more than 1/2. Simply because we don't detach the soil particles, they can't be transported away. Now the last one here, it's about a 95% cover. And again, underneath this is the same soil as I had here. It's just that we put a lot of residue on top. So we're going to absorb all the raindrop impact that we can. We'll still have some runoff because I'm going to put on water faster that can soak into this soil. And so we'll see water coming off here, but without the detached soil particles, that water will be a lot cleaner. Now coming on this side, this soil obviously looks a little darker than this one. This one I said was a tilled soil. It's rather loose, poured it into these greenhouse flats. This one's actually a no-till soil. It's a darker soil, it has better organic matter. But more importantly, it has soil aggregation. The soil particles and PEDs are holding together. Now it is loose and crumbly because I dug it up to put it in here. And in fact, when I dug it up, here's some roots even. Those roots would help anchor the soil. But I wanted to compare bare soil and bare soil. And so this has simply got some PEDs, some soil aggregation because it is a no-till soil versus a tilled soil. The tilled soil doesn't have near the biological life, thus it's a little lighter in color. This one's darker in color, better organic matter, better soil aggregation. Okay, we've started the rainstorm event now. As you can tell, the rain's coming down pretty fast here, but striking the soil surface, it's about as close to natural sized raindrops as you can get. This nozzle was selected for Rainfall Simulator research back in the early 60s. It's been used across the world for doing erosion demonstrations and research. Okay, we just saw the raindrop impact causing soil particle detachment. That same energy of the raindrop, though, was melting that soil surface and actually forming a crust on the soil surface. Without the residue here absorb that energy, I can reach down and I can actually pick up and get the crust to break off. A lot of people think a crust forms when the sun comes out and bakes it hard. No, the crust was formed right now during the rainstorm event, and it's about a 1/4 inch thick. It's a seal on top of that soil surface, and it flakes off there rather easily. And that seal on top then reduces how much water can soak in. And that's why we had quite a bit of runoff off of this plot. Now when I actually take a look at this, in the rain gauge, we are just over 1 inch of water applied. So that was a quick rainstorm event. We have a lot of producers out there in the middle of the summer who would wish for an inch of rain so it'd come help their crops out. But if we don't have a soil surface that will accept the water, a lot of it happens to occur as runoff. Now with that runoff though, we got the crust on top, we had more runoff. And that 1 inch of rain then, how far did it soak in? A greenhouse flat here is only about 2 inches deep. As I turn this over, we find dry soil in the bottom. That 1 inch of rain didn't even soak in. In fact, as I pull the dry soil away, it only soaked in about 1/2 inch deep. A 2 inch deep greenhouse flat has dry soil underneath. Because on a sloping soil, without something to reduce the crusting, without something to reduce raindrop impact, we have a lot of erosion and runoff because of that problem. Now, if we leave even a little bit of residue cover on the field, a 30% residue cover, we absorb some of the raindrop impact. When it comes to water soaking in, yeah, we had a little bit of water soak in, but it's about the same as with no residue cover. We still had some raindrop impact, still had some sealing, still had quite a bit of runoff and erosion. Now the last one, a lot clearer runoff, a little bit less volume there. In fact, these 2 jars overtopped. That third one with the residue cover did not. In fact, when I pull the residue away, we don't see the crust on top as I go to pick off the soil. So when I take the exact same soil, remember the only difference between these three plots was the residue cover on top, and I turn this one over, we definitely see greater infiltration. We can definitely see how that residue now let that 1 inch of rain soak in all the way through. Far more water available to the crop than here, and even less water available here. So zero cover, the 30% cover, the 90 to 100% cover. Remember, these were all the same soil poured in loose into those greenhouse flats. So we are not doing anything special there other than protecting it from raindrop impact. The residue cover does a lot for us. The next one here is the no-till soil. We see some soil pads, some soil aggregates holding together. And as such, yes, there's a mild crust there, but it's not near as dense. As such, more water soaked in. And when I turn this one over to see how much infiltrated, again, wet all the way to the bottom. This is no residue cover, but it had good soil pads, good soil aggregates. We can actually see the soil particles still holding together there. Compared to this one, where there was no residue as well, there's no soil aggregation to hold those soil particles together. So again, the difference here was soil structure because of continuous no-till, no tillage, good biological life. This one's been tilled, breaking up the biological life, breaking up the soil structure. The water can't soak in as much. So again, we get better infiltration when we get that long-term no-till